Hello students, welcome to the third part of polynomial where we will be talking about algebraic identities. Now we are talking about algebraic identities. To start with, what are the basic identities? The basic identities which we have learnt are x plus y whole square, x minus y whole square, x plus y into x minus y, and x plus a into x plus b. The four basic identities which we have already learned. Now what is x plus y whole square? X plus y whole square is x square plus 2xy plus y square. Isn't it? Then x minus y, simply substitute y as minus y. If you substitute y as minus y plus will become minus 2xy, and this is not going to change because the order is 2. So when you multiply minus sign 2 times, you are going to get the same answer. X plus y into x minus y is x square minus y square. Simply multiplication of these two will give you x square minus y square. The third identity where x plus a, fourth one is x plus a into x plus b will give you x square plus a plus b x plus a into b. Clear? Now using these basic identities, we will be getting few more identities. But before getting the few more identities, let's check the applications of these identities on basic questions. Now, for example, the first one consider as x plus 3 and x plus 3. See which identity we are going to use. The first thing we can see, if you take this entire as a and this entire as a, both are having the same variable with same constant and same sign. So you can write it as x plus 3 whole square. Now here you will be using x plus 3 whole square as a plus b whole square. Now what it is? A square plus 2ab plus b square, which is x square plus 6x plus 9. Clear? Now we'll check the second one. What happens if it is x minus 3 into x minus 3? We will be writing it as x minus 3 whole square, x square minus 2x into 3 and plus 3 square. So this is going to be x square minus 6x plus 9. Clear? So we have checked identity 1 and identity 2. Now we'll move to the third identity. Now what is the third identity? Let 2x plus 3 and 2x minus 3. Only the sign is changing. There we can go for the square. So what, as per the identity, it was 2x square minus 3 square, that is 4x square minus 9. Clear? What happens if it is 4x square minus 9? The second one, there we will be writing it as 2x square minus 3 square, which is a square minus b square. So if x plus a into x plus a and x minus a is equal to x square minus a square, and if this is given, we will lead to this, and if this condition is given, we are going to express it in this way. So it will become 2x plus 3 and 2x minus 3. All the identities are LHS equals to RHS. If LHS is given, we can express them as RHS, and if RHS is given, we can express them as LHS. Now let's see the fourth application, in which we have 2x square. We were talking about x plus a and x plus b, which lead to x square plus a plus b, x plus a into b. For this, we will be taking example as x minus 3 and x plus 3. Clear? X minus 3 and x plus 3. This can also be written as x plus of minus 3 and x plus 5. Clear? We will be writing it in this form, that is x square plus minus 3 plus 5x plus minus 3 into 5, which will be x square plus 2x minus 3 plus 5 is 2 minus 15. Clear? This is the practical application, and if we are not exactly remembering what to do, in that case x to be multiplied by x plus 5 minus 3 into x plus 5, which will lead to x square plus 5x minus 3x minus 15, which is x square plus 2x minus 15. See, in both the methods we are going to get the same answer. Clear? Now we have checked 4 of the basic identities, where we have seen the practical application also. Now let's move a bit further. Now we are going to take in 3 variables how to use the identities. Like if x plus y plus z is given as square. Till now we have done only for 2 variables, that is x plus y whole square. We can also apply the same one on this. How? Let x plus y be t. If it is t, then this becomes t plus z square. That is t square plus 2tz plus z square. Now exactly substitute what is x plus t. X plus y. T is x plus y whole square plus 2 into x plus y. We are substituting t here and t here. Plus z square. We are getting it as x square plus 2xy plus y square plus 2x. We have z also here. So 2xz plus 2yz plus z square. Arranging it properly, it becomes x square plus y square plus z square plus 2xy plus 2yz plus 2zx. Clear? This is our 5th identity, where we can say that x plus y plus z whole square is nothing but x square plus y square plus z square plus 2xy plus 2yz plus 2zx. So this was our 5th identity, which we are talking about. Now we will be seeing a few more identities, but before that let's take a practical example on this. Now the application of the previous identity which we have learned, 3a plus 4b plus yc square, where 3a is x, 4b is y and 5c is z. So recalling it as a x square plus y square plus z square plus 2 xy. X was 3a, x and y is 4b plus 2 into 4b into 5c plus 2 into 5c into 3a. Clear? X square plus y square plus z square plus 2xy plus 2yz plus 2zc. Only simple substitution to be done and simplify it. So this becomes 9a square plus 16b square plus 25c square plus 2 3s are 6, 6 4s are 24ab plus 4 5s are 20, 22s are 40bc plus 3 2s are 6, 6 5s are 30ac. That's all. The application of the fifth identity we have done. We will take two more examples. Now the next one is to solve 105 into 106 using the identity, practical application. Now which identity will be used here? Which identity can be used here? See, we can use 100 plus 5 and 100 plus 6. Clear? What it is? It is like ax plus a into x plus b. Recall it, what it was? X square plus a plus b x plus a into b. That's all. So now use it. X square is 100 square plus a is 5, b is 6. 5 plus 6 into 100 plus 5 into 6. This means 10,000 plus this is 11. 11 into 100 is 1100 plus 30. Now this is going to be 1. So the answer is, when you add 0, 3, 1, 1, 1. If you practically multiply and see, you are going to get the same one. What it is? 105 into 106. 6 5s are 30. 6 0 0 0 5 0 and 1. 0 3 1 1 carry 1 1. See, we have used the identity and solved the same thing we can get, but this is not expected by higher class kids. Clear? Now we will be taking one more example. The next example which we will be taking is 49a square plus 70ab. 25b square. Clear? The example is 49a square plus this. Now which identity will you use? See, as I told you, LHS can be transferred in the form of RHS and RHS can be transferred in the form of LHS. So we cannot find a process here where we can see that it is a plus b whole square, a minus b whole square, or a plus b into a minus b, or a plus x plus a or x plus b. What is exactly this is? So if you see, this is a perfect square for 7a square plus, forget about this. This is about 5b square. Now a square plus b square. Did you recall something? Yes. 2 into 7a into 5b. 7 5s are 35. 35 2s are 70 and ab. Clear? So this is in the form of a square plus 2ab plus b square, where a is 7a, b is 5b. So we can write it in as 7a plus 5b whole square. These were the very simple application where we have used only the basic 5 identities. Let's use some complicated examples also. So we will be taking up now this polynomial where x square y square plus 2x plus 1 is given. How to start up with? See, we can know that the degree is 2. Two variables, we have x and y. We'll be rearranging it. How will we rearrange it? Minus 2x plus 1 minus y square. Treat this as 1. Clear? So we can observe something here. What we are observing? A square plus 2ab, b is 1, plus 1 square is 1. So this is x plus 1 whole square. Remaining is minus y square. This is in the form of a square minus b square. Now recall the identity. A square minus b square is a plus b into a minus b. What is a? This is a plus b. What is b? Clear? Isn't it so easy? Now, a power 4 minus 16 b power 4. With power 4, we didn't have any of the identities. This can be written as a square whole square minus 4b square whole square. When you simplify this, a power 2 into 2 is 4 and 4 square is 60, b square into 2 is power 2 will be b power 4. This is in the form of a square b square, where a is equals to a square and b is equal to 4b square. So a square minus b square was nothing but a plus b into a minus b. That means this we know. This part we know. So we will be practically using it. Let's write a plus b into a minus b. Yeah. Now this part cannot be changed. We cannot write anything here. But the second part can be further simplified. Now when it is further simplified, this is nothing but a square minus 2b square. So a plus b into a minus b. Like factorization need to be in the simplest form. So if we take one more example based on the same one, see the next example which we are taking is 116 into 116 minus 106 into 106. Now will you practically multiply 116 into 116 and then subtract the answer by 106 into 106? No. We will be doing smart work here. So this is 116 whole square minus 106 whole square is equal to 116 plus 106 and 116 minus 106. So when you add, this is 6 plus 6, 12, 2, 1 carry, this is 2 and this is 2 into 6 minus 6 is 0, 1 minus 0 is 1 and 1 minus 1 is 0. So the answer is clear? So these were the practical application. Let's check some of the identities with cubic identities. How to find the cube of. Now cubic one, x plus y whole cube. This can be also written as x plus y into x plus y whole square. We can also write it as x plus y, x plus y, x plus y. But that will not solve our purpose. So we have x plus y. This will be written as x square plus 2xy plus y square. We are expanding x plus y whole square. Here multiplying it by this, so x cube plus 2x square y plus xy square plus x square y plus 2xy square plus y cube. Rearranging it, x cube plus y cube plus 2x square y. See, x square y and x square y. So we have 3x square y. Similarly, plus 3x y square. On further simplification, this will give you 3xy taken as common. We are taking from x square, xy common, 3 common, xy common. What we are left with? X. And what here we are left with? Y. Clear? So this is x plus y whole cube. What it is? X cube plus y cube plus 3xy. Now if this is the value of x plus y whole cube, what will be x minus y whole cube? X minus y whole cube will be x cube plus minus y cube plus 3x minus y, x plus minus y. That is x cube minus y cube minus 3xy into x minus y. This is the value of x minus y whole cube. Now, we can see the practical application of cubic identities. 3a plus 4b whole cube, where a is 3a and b is 4b. So that now 3a plus 4b whole cube is a cube plus b cube plus 3ab into a plus b. Now 3a cube is 27a cube, 4b whole cube is 64b cube, plus 3 3s are 9, 9 4s are 36. 36ab into 3a is 108a square b, and 36ab into 4b is 144ab square. So this is the final answer for a plus b whole cube using the identity 3a plus 4b whole cube is finally giving a result of 27a cube plus 64b cube plus 108a square b plus 144ab square. Similarly, when we check for the example of 5p minus 3q whole cube. Now when we are checking for this, a cube minus b cube minus 3 into ab into a minus b. A cube 5p cube is 125p cube minus 3q cube is 27q cube minus 3 into 5 is 15. 15 3s are 45, and that multiplied by 5p minus 3q is 225p square cube plus 135pq square. Similarly, we can find the values for 104 whole cube. Now 104 whole cube is nothing but 100 plus 4 whole cube, where a is 100 and b is 4. So 100 cube plus 4 cube plus 3ab, that is 100 into b into a plus b. But on further simplification, we are going to get the value as 1124864, that is 11,24,864. Now when the next example considering 999 whole cube, 999 whole cube. So this can be represented as in this form, and on simplification we are going to lead the conclusion in this way. A cube minus b cube minus 3ab into a minus b. So solution of this is resulting to this. Now let's take our last one more example for checking the identity, and then now factorize 8x cube plus 27y cube plus 36x square y plus 54xy square. This is a perfect cube, 2x is cube, 27y cube is again a perfect cube, 3y whole cube. 36x square y can be written as 3 into a square b, and 54xy square can be written as 3a into b square, which is nothing but in the form of a cube b cube plus 3a square b plus 3ab square, which will result to a plus b whole cube. A is 2x, b is 3y cube. Okay. Now we will take a last identity. The last identity is a cube plus b cube plus c cube minus 3abc, or x cube plus y cube plus z cube minus 3xyz is nothing but x plus y plus z into x square plus y square plus z square minus xy minus yz and minus zx. Now practically we will check it on the factorization of the given polynomial. It is 8x cube plus y cube plus 27z cube minus 18xyz. We can see that this is a perfect cube, this is a perfect cube, this is a perfect cube. 2x cube plus y cube plus 3z square. Whereas this term we can get it by 3 into, this is 3 into, a is 2x, y and 3z. So what we are getting finally is, taking this as common one, see, expanding this side from this, that is LHS to RHS. This is in the form of LHS and we are expanding in the form of RHS. Where this is x plus y plus z. X is 2x, y is y, z is 3z. A is x square, y square, z square minus 2xy minus yz and minus zx. Further simplification, this will remain as it is. This is going to be 4x square plus y square plus 9z square minus 2xy minus 3yz minus 3zx. Clear? So, with this, we have completed all the 8 identities of algebraic expression under factorization and polynomial. So, we will be ending our session for this. Thanks, and do solve the assignments.